Hey guys, I noticed in the last couple videos that my sound and my writing was a little bit off. I'm not sure what happened, but hopefully I fixed it. Sorry about that. We are in 4.3 and we have been talking about using the first derivative test to find relative extrema. Remember that when my derivative changes from positive to negative, we have a relative max, and when my derivative changes from negative to positive, we have a relative min. So let's do example number 2c, adding a little trig in there. And so we have to follow a few steps in order to find relative extrema. The first thing we have to do is find our derivative. So practice your derivative rules, find the derivative, and see if you got the same answer as me. I ended up with a 1/2 minus cosine of x. The next thing we need to do is find our critical numbers. That's when our derivative equals 0 or does not exist. So I'm going to set my derivative equal to 0. I'm then going to solve that trig equation. So I ended up getting a cosine x equal to 1/2. I can inverse cosine both sides and use my unit circle to figure out where on the unit circle does cosine equal 1/2. And I ended up getting at pi over 3 and 5 pi over 3. So those are my two critical numbers. That's when my derivative equals 0. That's where I have a place in my function that is constant just for a second. And so now I can go to my sign chart, test values in my derivative to see if my derivative is positive or negative. So I need you to pick a number that is less than pi over 3. I need you to pick a number in between pi over 3 and 5 pi over 3. And then I need you to pick a number greater than 5 pi over 3. We're going to plug those numbers into our derivative to see if our derivative is positive or negative. So what's a value on my unit circle that's less than pi over 3? I chose pi over 6, and so I can test that value in my derivative to see if my derivative is positive or negative. When I plug in pi over 6 into my derivative, cosine at pi over 6 should be rad 3 over 2. So I end up getting 1/2 minus rad 3 over 2. Well, rad 3 is a little bit bigger than 1. So 1 minus something bigger than 1 is going to end up giving me a negative value in my derivative in that interval. I'm going to plug in a number in between pi over 3 and 5 pi over 3. I just picked pi. I'm going to plug that into my derivative. Cosine at pi is -1, and so 1/2 minus a -1, or 1/2 plus 1, ends up giving me a positive value in my derivative in that interval. One more time, picking a number greater than 5 pi over 3, I ended up choosing, 11 pi over 6. I plugged that into my derivative, and I ended up getting 1/2 minus rad 3 over 2 again, which is negative in my derivative. So now that I know that, we should be able to tell that my function decreases, increases, and then decreases again. So not only would I be able to figure out where my function increases or decreases, we can also use that first derivative test to find me my maximum, relative maximum and relative minimum, my relative extrema. And so when my derivative changes from negative to positive, I know that I've just found a relative minimum. When my derivative changes from positive to negative, I know that I found a relative maximum. But remember, those are points, x comma y's, and so we might have the x values, but I need you to help me find the y values. So remember, we want to plug in those x values into our original function so that we can find the point on my original graph where I have a minimum and where I have a maximum. So pause your video, plug in those values, and see what you get. So I ended up getting a relative maximum at 5 pi over 3, 5 pi over 6 plus rad 3 over 2. I know it's not beautiful, but that's an exact form. I know that there's a relative maximum there because the derivative changes from positive to negative. I got a relative minimum at pi over 3, pi over 6 minus rad 3 over 2. Because that's when the derivative changes from negative to positive. So those are exact values where I have relative mins and maxes using the first derivative test. A little bit of trig in there, so please, please, please make sure you know your unit circle. Remember that I have blank ones in Canvas that you can print out and practice so that you know those values.